You hear me? Okay, so day 2 evening, almost the end of today. I don't see many people here, but I just see the people who are still staying here are true lover to GTI. I see. Oh, cool. Yeah, they are online lover to GTI. I see everyone is very tired, but I'm just saying, I just ask people here to remember, and I just want to address 2 keywords for today. The number 1 keyword is CNN. The CNN is not the CNN in the US. That's the CNN Computing Native Networks. Number 1 keyword. And the second keyword is JC&C. It's joint communication and computing. On the other hand, in other words, we call it ISAC. The integrated sensing, computing, and communication. But it's the evolution of joint C&C. It should be called ISAC squared, right? Because of the 2 C's, communication and computing. Anyway, let's go to the agenda today. First is a quick recap about Asia Info Technologies. And the second part of my topic is to address these 2 keywords, CNN and JC&C. About Asia Info Technologies. In reality, Asia Info Technologies is China's largest telecom software company, worldwide number 2. We are actually founded in Dallas, in US, 30 years ago in 1993. And then we moved to China, and then we actually devoted ourselves in the telecom software business from 1G to 5G to the telcos in China and worldwide. And in 1999, in the end of 1999, beginning of 2000, Asia Info is actually the first China's high-tech listed in Nasdaq back to almost 23 years ago. And then we moved forward, and 3 years ago, China Mobile took Asia Info's 20% of the stake 3 years ago. And we are here still to continue our business in the space of the telecom software space, working closely with China Mobile and all the other telcos in APAC area. And then let's go to the formal topic for today, leverage CNN for joint communication and computing. First, we sought out a lot of literatures back to 3 years ago. There are almost, I would say, 39 formal white papers about 6G issued by different organizations, vendors, and telcos worldwide. And then we conclude, we take out all the common topics and conclude the top 15 6G tech candidates. Some of which that I highlighted with orange color. Take a look at it. Integrated sensing, computing, and communication. On the other hand, the coordination of computing and networking. In this morning, Mr. Gao Tongqing addressed the second orange highlighted word, coordination of computing and networking. In China, telcos call it 算力网络, but in International Telecom Union, in ITU, it is officially defined as this word, CCN. Coordination of computing and networking is a joint proposal by China Mobile, China Telecom, China Unicom, along with some other vendors worldwide. While I highlight these 2 words, take a look at it. Literally, all these texts will be realized by what year? 2030, right? That's going to be the year 1 of 6G. But take a look at it. Some of these technologies, otherwise partial technologies in this graph, can be first deployed before 6G. It's just like the integrated computing and communication. In my words, I point to joint C&C, for example, joint computing and communication definitely can be realized before 6G. That's the most topic I want to address for today. And computing and the coordination of computing and networking, otherwise in Chinese we call it 算力网络, is going to heavily use the JC&C tech. All right, next page. There are 2 options for the telcos nowadays to realize JC&C joint communication and computing. Let's take a look at the option 1, this way. All right, a lot of hardware vendors come to the telcos, say, hey, China Mobile, if you want to roll out more and more, let's say, network and cloud convergence based networks, okay, I have so many hardwares for you to purchase. Go ahead, China Mobile, buy more and more computing cards, buy more and more GPUs from me. Okay, I give you a good deal. That's option 1. So telcos may burn a lot of money, extra money, to buy extra computing cards or servers at their edge, at their IDC center. That's option 1. Definitely, that is not a cost-effective way for telcos to deploy JC&C. Option 2, that's what we are recommending. Through this way, we call it computing native networks. That's the way to really realize the JC&C in a cost-effective way, completely through software-based definition. All right, what's that? First off first, just remember this word, CNN, computing native networks, CNN, and then I will address it in detail. For example, this is the key components of China Mobile or every telco's 5G network infrastructure, 5GC, some of them also including 4G EPC, and then in the wireless side, BBU, RU, and then MAC, the mobile edge computing service over there. Those are the key components in the 5G network infrastructure right now. Okay, so what we are doing now is we don't want the telcos to burn money to buy the extra computing cards or GPUs or CPUs for their computing networks. Actually, in reality, particularly in China, the average network utilization is very low. I used to be alumni in T-Mobile and Verizon in the US. The average network utilization in T-Mobile and in Verizon is no higher than 60%. But this figure is still high somehow to the telcos in China. The reality in China is the telcos, for example, China Mobile, you know how many gigabits and the 4G base stations they deploy, right? The network traffic is high. However, the network capacity is even higher. The average network utilization in China is lower than 40%. Which means what? Which means most of the network utilization was spared in the non-busy time can be spared out for what? For computing purpose. That's what we are doing for now. For example, take a look at the BBUs, otherwise GNODBs. We do what? We do pooling. So we set up a couple of the BBUs as a BBU pool over here. In average, in one BBU, there are in average 13 to 16 CPUs. Some of them also including some GPUs. In average, 13 to 16 CPUs in every BBU. Okay, but not all of them are busy as usual at any time. So what we are doing now is we roll out a JC&C scheduler and the orchestrator in 5G MAC in the remote site. The scheduler and the orchestrator in the remote site, northbound wise, it goes to the southbound connecting to the awareness unit in our BBU. The awareness BBU, you can consider is an instant detector to measure and to detect the instant resource utilization related KPIs. Northbound wise, it reports the instant KPIs to the scheduler and demonstrator. The scheduler and orchestrator in the 5G MAC can sense the prospective resource utilization. It determines if they can spare some CPU or GPU resources in each BBU in the future, in the next couple of hours. So that is the CPU, obviously, that is the brain of all the CNN networks in the 5G MAC. So that is the CNN for 3GPP. What about the other side? What is about the CNN for O-RAN? That's our deployment architecture over here. We also split the overall mechanism into two parts. The first is still the awareness unit. In 3GPP, we embedded it inside the BBU, but in Ouyang side, we deploy it in what? In near real-time RIC, rather than the 5G BBU in the 3GPP mode. And then the awareness unit is in terms of one of the apps in the X app library in the near real-time RIC. That's the near real-time site. And then northbound. Northbound is another name. We call it what? We call it non-real-time RIC. You know it exactly in the Ouyang architecture. Which means what? Which means the JC&C scheduler and orchestrator is a typical app in the non-real-time RIC. That's our deployment architecture for Ouyang. 3GPP and Ouyang, different modes. And then benefits. The three key benefits, I would call it less investment, more resources, and higher capability. So less investment, in Chinese we call it 投资做减法. The investment is going down because of what? The telcos are no longer needing to buy the extra hardware for their computing resources, which means they can spare the additional and non-busy resources from the network for the computing purpose. And then second, more resources. We leverage the TDMA mode to spare the resources for communication back to the for the computing services over here. So the TDM mode for us to convert the resources between communication and the computing back and forth. Last, higher capability, which means what? Which means you don't need to spend extra money and buy the extra computing cards at the edge. The traffic load in the 5G MAC is going to be significantly reduced, which means we can leverage the 5G MAC for other applications. Three key benefits. I need to speed up. And then 6 key techs in CNN. First, the overall mechanism of the joint communication and computing are completely virtualized. That's the number 1 key tech. Number 2, so we put the scheduler, we put the overall scheduler and orchestrator as the edge side. So we push it to the edge side. That's why we push it to the edge side, because we want to realize number 3, network lossless. We don't want to break, or we do not want to jeopardize what? First, we don't want to break the existing 3GPP network architecture. Number 2, we don't want to break the existing protocol stacks in air interfaces and the interfaces in the 5GC. Number 3, QoS lossless, which means what? Which means the queues for the communication is always top priority. So the algorithm for in number 4 key tech, the algorithm for us to schedule and to orchestrate the resources, switch back and forth between the communication and the computing should be following these 3 patterns. Particularly for the number 3, we always want to guarantee the queues for communication as top priority. That's number 3 and number 4. Number 5, after you realize the CNN for the joint communication and the computing, what you want to do? You want to deploy the computing services, right? But what computing architecture that you want to deploy over the CNN networks? Definitely, that is the federated learning. We are the first vendor to collaborate definitely with China Mobile to deploy the federated learning over such computing native networks in the past year. And number 6, that's for the simulation and planning. We also deploy our computing. We also deployed our digital twins networks testing beds. And right now it has been a fully commercialized, launched to co-work with the network department in CMRI, in the Student Health Department for CNN as well. 6 key techs. And then let's see the testing and validation results. So we have plan A and plan B. Plan A is CNN. We have the 5G BBU with the CNN functionalities activated. That's plan A. Plan B is what the traditional deployment patterns, that you have your standalone BBU, and also you deploy your 5G MAC for computing. So BBU for communication only. ECS, the edge computing server for computing only. Then plan A is the joint communication and computing. And then in this experiment, we run a testing tool named real-time app. That's a simple testing tool to simulate a lot of tasks, computing tasks with multiple threads periodically. And then we run 30,000 loops, and the sampling period is 1 second for us to capture each KPI. 3 critical KPIs we capture over here. First is the overall running time for plan A and plan B. And then second KPI is definitely we want to compare the utilization of the CPU. And then number 3 is the power consumption. Definitely we are expecting plan A will save more watts power. Plan A will save more watts, more CPU utilization. Let's check out the results. Okay, on the left side is always plan A. On the right side is always plan B. All right. So take a look at the left side. The x-axis is the time. The y-axis is what? Take a look at. Is the CPU utilization. Okay. So if we run the joint communication, plan A, the joint communication and computing in our plan A, you will see the running window is longer than the standalone mode. The standalone mode is you have a dedicated 5G MAC server to run computing tasks. So take a look at the window length in A is larger than the length in B, which means what? If I run the JC&C mode, it takes more time to finish what? To finish the computing task than the dedicated computing server, a little bit. And then, but let's see the significant benefits. Take a look at the power consumption. The power consumption, the x-axis is also the time per second. The y-axis is the power consumption in terms of watt. All right, take a look at the plan A with JC&C mode, joint computing and communication. The average power consumption is 38 watts. And then let's go to the plan B. That's a dedicated BBU and a dedicated computer. The power consumption is higher than 140, significantly higher than the plan A over here. Let's see the benefits over here. And then let's see the overall power consumption. The x-axis over here is also the energy consumption, how many watts it consumed. And then the y-axis is the time. For example, with plan A, the overall running time is about 300 seconds. But for plan B, the overall running time is about 200 seconds. And then X times Y is the total power consumption. Take a look at it. Definitely, the red box is smaller than the blue box. What does that mean? That means the power consumption-wise, then we convert it to the money and dollars. Obviously, we see the power consumption in terms of the cost comparison. If you take a look at the results, with the plan A, the JC&C mode, it saves more than 70% of the obviously the power cost over here. That's the experiments we have done at the beginning of this year. And then production-wise, our GNODBs, our BBUs are fully embedded with the CNN and JC&C functionality. And we have get the 4 certificates from China's Ministry of Industry and Information Technology Department, like US FCC. And then our 5G MAC is also fully compatible with the CNN scheduler orchestrator, which means our private 5G products is fully compatible with the computing native networks already. And then let's take a look at the very typical scenario in nuclear power industry. Everyone knows obviously the negative, the news that's a neighbor country from China recently is discharging the nuclear wastewater, right? But in nuclear industry, it's really serious. Take a look at the nuclear working zone. For example, in China, nuclear power plants. Every year, the workers in nuclear industry cannot enter into the nuclear islands, otherwise you call it nuclear production zone, every day or every month. Spreading out the 12 months is there are 1 or 2 windows, no more than 15 days each year, you can enter into the production zone for the diagnostics or repairing work. So the nuclear industry do not want to burn money to buy the extra computing, servers for example, for the remote diagnostics, right? So we can do what? We can deploy the private 5G with the CNN functionality over here. Then, in every year, the private 5G networks deployed inside the nuclear production zone can be activated with the CNN functionality by us. And then the workers, we don't care if he really enter into the production zone or he wants to perform the remote diagnostics with the AR glass, can be running on top of the CNN network in the nuclear power plant over here. That's a very typical, application scenario for CNN. And then that is obviously that's our private 5G along with the CNN functionalities that we have deployed for China's power industry across China, including the hydropower, nuclear power, electricity power, or wind power. So private 5G along with CNN is a very greenfield scenario that can be applied to vertical industries. We have done a lot of scenarios, such as CNN-based application scenarios for the power industry already. And then let's take a look at the short video. Turn on the volume. Can you? Ready? Some cutting-edge text that I want to share with everyone. Since Asia Info co-work closely with China Mobile. We are also the largest telecom software vendor in China, so we co-work with China Mobile along with Tsinghua University and a few other vendors to publish the work, I would say worldwide is the #1, the first white paper in the space of 6G OSS and 6G BSS. And additionally, about ORAN, that's the first Open RAN book in the world that I authorized and published. And English version is on the way by the end of this year by Springer. Take a look at it, and feel free to scan the QR code, and we are happy to meet again. Thank you.
Thank you, Mr. Ouyang. Questions? Mr. Ouyang.
Do Asia Info now go into hardware manufacturing as well? Because
yeah, this is a great question. So it's like the mutual penetration. The traditional hardware vendors are also doing a lot of software stuff right now. And on the other hand, we are doing some software and hardware integration. You know that, right? Network virtualization. You can do it from the software side, otherwise you can do it from the hardware side, right?
The first one is you said the computing capacity between the GNOB, MEC, and the server. So I want to know, is there any the computing content? What's the difference? The computing contents between different network elements. Is there any communication between the different network elements about the computing result?
Hello, you hear me?
Huh?
Oh yeah, yes. Yeah. Computing content-wise, we do not do the differentiated QoS stuff over here. We just, because we want to compare apple with apple. Plan A and Plan B, we run the exact the same. Everything in your words is computing contents. In my words, it's the same computing app over here. And then your second question, overhead-wise, I didn't see any additional overhead cost staying between the different nodes because we didn't break or didn't destroy the existing protocol stacks. The scheduler and orchestrator is installed in the 5G NAC. So the 5G NAC is connected. Source bound-wise is connected. It's going to what? It's going to video through a dedicated Ethernet cable over there. So it doesn't cause additional bandwidth or it doesn't cause additional overhead inside the 5G network. That's my response.
Okay, yeah. Thank you. Another question. I said in your presentation, you said you didn't suggesting the actual computing board, but you know the baseband board is designed according to the communication capability. So if the communication and the computing complex, how to design?
Yeah, this is a very good question. So I would say the telcos do not use the option 1. So option 2 is optimized way for the telcos to save their capex and capex and the total cost of ownership. For example, I take another example for you, FYI. Right now, all the 5G BBUs are what-based? Are CPU-based. What if that you want to run some GPU-based computing tasks? In here, the 5G BBU cannot fulfill the GPU-based computing tasks. So that means what? You have no more choice. You have to go to NVIDIA and say, hey, I have to buy your GPU servers and GPU computing cards. But moving forward, particularly in the ORAN family, the 5G BBUs, obviously more in the CPU side, will embed GPUs in the future, which is underway by a couple of ORAN vendors right now.
Thank you.
Okay.
Can you hear me? No, I guess not.
Yeah, go ahead.
We hear you.
Oh.
We hear you.
Oh,
Go ahead.
that's great. Because my previous questions were not heard. But I think the lady just raised the question I want to ask. So now you're supporting a general purpose CPU-based architecture. And you just mentioned that the GPU-based architecture maybe could be. My question is, could GPU-based architecture or other maybe a processing unit-based architecture could be one of the direction in the future to be adopted in the big new base stations, to support all kinds, various kinds of computational tasks.
Yeah.
That is my question.
Yes, you're right. Having said before, the GPU is on the way, for the prospective CU in the Ouyang family. Some of the Ouyang vendors is on the way to do some pilot trials. I don't want to disclose their names. But on the other hand, let's think about the GPU. Let's say if we embed the GPU inside our BBU or CU in the future, will this GPU card only work for what? For computing. Otherwise, can the prospective GPU work for our communication? That's still a question TBD. We need to discuss it in detail. In the existing communication mode inside BBU, we do not foresee any necessary, requirements that we need to, run a GPU for our communication tasks. But who knows in the future? Probably some sensing tasks or some other new tasks in 6G may need a GPU. So it's still a question TBD. FYI.
That's right.
Yeah.
In LTE times, the majority of the base stations were implemented using ASICs or maybe quite task dedicated to communication processing. In 5G, I don't know how many. What's the percentage of 5G base stations where you have used the general purpose processor? So
you are exactly right.
Yeah.
You are exactly right about the ASIC. So honestly, I had a talk with one of the experts in China, academia from China engineering academy, who suggested me, take a look at, because he's a pioneer in AI space. He suggested me take a look at the ASIC boards inside the BBU, if it can be spared in the future for the joint communication and computing. But it's still a TBD topic that we can discuss it in the future. Leave me your contact information. Probably we can discuss it offline.
All right, thank you.